Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Very warm welcome to today's session. This is going to be session number 4 for CBC ninth on motion. Before we get started, let me introduce myself. My name is Anu Manoharan and I'm a master teacher of science here with Antu. A very warm welcome to all of you guys out there. So today we'll be talking about the graphical derivation of equations of motion. That's what we're going to do in today's session. But before that, as always, there's a quote waiting for you. And the quote for today is this, guys. The future belongs to those who believe in the beauty of their dreams. So yes, guys, all I'm trying to say is this: believe in your dreams, give your 100% for that, and one day for sure your dreams will also come true. Make sure that you believe in it. That is very, very important. All right. Anyway, so that's it, guys. Let us get started with today's session, where we'll be talking about the graphical derivation of equations of motion. So before we get started, guys, in the last session of motion, I had asked you a homework question, and many of you guys gave the answer for this one. So here, this was the question: in the graph given, in which time interval the distance covered is maximum. So that was the graph. You're supposed to find out in which time interval the distance covered was maximum. Just by looking at the graph, you can directly tell the answer that it is between 0 to 1 second that the distance covered is maximum, because he has covered a distance of 4 meters, whereas between 1 to 3 seconds his distance is standing still. That's why it's a straight line, horizontal line, parallel to the x-axis. Then we also have between 3 to 4 seconds he's done about 2 meters more, and between 4 to 5 seconds he is again in the state of rest. So clearly, guys, 0 to 1 second is where he has covered the maximum distance. So that is the answer. So these are some of the superstars. Once again, we have Sureka, Amaya, Nagraj, Rekha, Natik, and also Vidya Shankar. Congratulations, guys, superbly well done. Hats off. I hope to see more such answers from you guys in the next session as well. So this is the thing, guys. We'll be talking about the equation of motion. First of all, let me just state the equations of motion. What are those equations of motion? So you have three equations of motion. The first one is V is equal to U plus AT. Second is S is equal to UT plus half AT square. And then you have V square is equal to U square plus 2AS. Now, I'm pretty sure that all of you guys are well aware of this equation. Do not ever forget this, because these are things that you should never forget. You would have this in your higher grades as well. So it's always better never to forget it, or don't just study this for the sake of your exams, your final exams. Study it so that you can retain it for the rest of your life as well, right? So anyways, guys, let's consider a person. Let's consider a person to understand this, all right? Let's consider a person who's walking in a straight line with a uniform acceleration A. So his initial velocity is U meter per second, and his time taken is 0 seconds. At P, or basically at some point P, let's take it as P itself, or let's the person is P, so let's take some point as he's not in the state of rest, so he already has an initial velocity. At time taken is 0, and let's say his final velocity is V meter per second. I don't know what his final velocity is. Time taken is t seconds, and then acceleration is a meter per second square. So what I'm going to do is that I'm going to represent all of this in a graph. So I'm going to take a velocity time graph, represent this, that is the initial velocity and the final velocity, and the time taken as well. So time taken would be in the x-axis and the velocity would be in the y-axis. So it's a uniform acceleration. It's clearly mentioned that the body is moving in uniform acceleration. So it is going to be a straight line. We've already seen that in the last session. So it's going to be a straight line, which is basically what is represented over here. So it's a linear line. So it's a linear graph. So what I'm going to do is that I'm going to take this point as 0, or I'm going to take this as the initial velocity, and I'll take some point as the final velocity. All right. I don't know what is the initial velocities or his final velocities. It should be anything other than 0. Initial velocity, because of the fact that he already has some velocity, I can't take it as 0. So I'm going to take it as U. So I'm going to take some point on the graph on the x-axis or on the y-axis as U. So what I'm going to do, I'm going to join those two lines. I'll get this graph. So this is 0, the coordinates are 0, U over here, and here it's t, V. Simple as that. All right. Now, here's the thing, guys. This distance is U, and this entire distance is nothing but V. Very simple. That is U, this is V. What I'm going to do is that I am going to basically make my life a little easier, because if you want to find out if you want to find out the displacement, you have to find out the area under the curve. So you can either find out the area of the trapezium, or you can divide it as a right angle triangle and a rectangle, and you can do the same. So what I'm going to do is this. So I'm going to name all these parts. I'll take it as A, B, C, D, and E. So I found out that this distance is U. So basically D is U, and this entire distance, that is from V to O, this distance is nothing but V. So I'll take it as C is nothing but V itself, final velocity V. Now I'm going to find out what is the acceleration. So what is the formula of acceleration? Acceleration is final velocity minus initial velocity divided by time taken. Very simple. Now in this case, what is V? V is nothing but C. V is nothing but C. What is u? U is d. Very simple. So what did I just find right now? So what I'm going to do is that I'm going to represent all of this in the equation. So what I'm going to do, I'm going to write this equation as AT is equal to V minus U. Basically, I'm going to take T to the other side. I'll get this equation. In place of V, I'll put it as C. And in place of U, I'll put it as D. Very simple. Now, what is this? This entire distance minus, okay, wait a second guys, sorry about that. Clicked on something else. So that distance minus, so I'll just erase this because that looks a little weird. So yeah, this distance, whatever is this distance, minus this distance would give you this distance. Very simple. So basically CE minus DE would give us, DE would give you CD. So what is CE basically? CE can be written as this entire distance CE can be written as CD plus DE. Very simple, CD plus DE. Very simple. From the graph, I can write that. So in place of DE, I'm going to substitute it as U. And in place of CE, I'm going to substitute it as V. And in place of CD, I'll put it as AT because why? Like I saw in this equation, this is what I found out. CD minus DE is nothing but V. One second. So I found that as CD minus, that is this distance, this entire distance minus this distance. I found out this distance. So AT is what? This is nothing but AT. That is what is AT. So I'm going to substitute that over here. So if you rearrange this equation or put that values in this equation from the graph, you will get the first equation, that is in place of C I put it as V, in place of D I put it as U, and in place of CD I put it as AT. Why did I put it as AT once again? Because I found out that CE minus D would give me nothing but CD. And what is CD? From this equation you can say that CD is nothing but AT because that is what you get. So if you do that, very simple, that is your first equation of motion, that is V is equal to U plus AT. Very simple guys. You just have to what to say, substitute in the formula of acceleration. Just substitute the values, you'll get the answer. As simple as that. Now what I'm going to do right now is I'm going to find out the displacement of the graph. Now what is the formula for displacement? It's my velocity time graph. To find out the displacement, I have to basically find out the area under the curve. So I have to find out this area. Now I have two ways to do it. One by using the formula of trapezium, or I can divide that into a right angle triangle and a rectangle and then find out the areas. So basically this is what I'm going to get. So length into breadth is what, so half into length into breadth would give you the area of BCD, and length into breadth would give you the area of ABDE, which is nothing but a rectangle. So this area and this area I'm going to get. So this area, that is a BCD, and I'll also get this area. I know it's a little messy. I'll try to erase all of these unwanted or the ones that I've already written so that I can make it a little clearer for you guys, because yeah, I have a very clumsy handwriting. Yes, so yeah, so you found out this area first. You found out this area, the area of the rectangle. So the area of the triangle and the area of the rectangle, add that up, you'll get the answer. So what is AE? AE is nothing but T. And what is DE? DE is nothing but U. So U into T is what you're going to get as the area of the rectangle. And over here you'll get as half into, what is the base is BD. BD is nothing but T into, or we'll take it as BD for now. So BD into the height is nothing but CD, which is nothing but 80. If you, from the last equation we got is 80, so nothing but CD. So CD is nothing but 80. Substitute the values in that equation, so that you'll get it as half into BD into CD. So, and over here you'll get as A into DE. So you'll get as 80 for the first one, and the second one you'll get it as half into 80 square, because it's 80 into T, you get it as 80 square. Add them both up, you'll get it as V is equal to, sorry, S is equal to, that is the distance. You're finding out the displacement, right? So displacement is equal to UT plus half AT square. As simple as that. So if you find out the acceleration, you'll get the first equation of motion. If you find out the area, you'll get or if you find out the area of the curve, you'll find out the displacement, which apparently is also the second equation of motion. Now you could use the equation of the trapezium as well to find out the displacement. You can use that as well. That will also give you the exact same answer. So this is the second equation of motion. You could, again, like I told you, you could also use the the area of trapezium wala formula, that is half into the sum of the two parallel sides, that is BD into CE into the distance between them, that is, sorry, BA plus CE into AE, that is the perpendicular distance between them. That will also give you the exact same answer. So if you use that as well, you'll be able to get the right answer. All right. Now For the third equation of motion is, to find out the third equation of motion, what I'm going to do is that, for this also I'm going to find out the displacement itself. I'm going to find out the displacement. So what I'm going to do, I'm going to use the area of trapezium this time to find out the area of to find out the displacement again. So I'm going to use the area of trapezium, that is what, half into BA into BA plus CE divided by, sorry, into AE, you'll get the answer. So sum of the two parallel sides into the distance between them. So this is the equation I'm going to get. Now, in place of AE, I'll take it as T. So what is AE? AE is nothing but T. What is BA? BA is nothing but U. And what is CE? CE is nothing but V. So I'm going to substitute all the values over here. So I'll get it as half into V plus U into T. Now, from the first equation of motion, we got A is equal to V minus U divided by T. So to find out T, what is T? T would be equal to what? V minus U divided by A. Very simple. What I'm going to do is that I am going to substitute this equation in the first equation. Alright, in place of T, I'm going to put that. So what will I get? S is equal to half U plus V, sorry, V plus U, whatever, into V minus U whole divided by A. As simple as that. Now what are you going to get? You're going to get V plus U into V minus U whole divided by 2A. Very simple, guys. Multiply it, what will you get? So S is equal to V square. If you multiply it, you'll get the answer as something like this. So you will get it as V square minus U square. So if you multiply it, what will you get? So it'll be V square for the, that is, if you multiply, one second guys, let me just erase that. So what will you get? You'll get, if you multiply this into this into this, this into this, and this into this. So if you multiply it, you will get it as V square minus U square. And on the other side, you have 2A, the denominator is 2A. Take that to the other side, you get it as 2AS, which is equal to V square minus U square. So if you rearrange the equation, you will get as V square is equal to U square plus 2AS. Or if you want to keep it like that, that is also fine. So V square minus U square is equal to 2A. So that will be the third equation of motion. I know these are pretty simple, but then yes, you have to remember a couple of things. Once again, I'll just repeat it quickly, guys. For the first equation of motion, what did I do? I just found out the acceleration. So rearrange the equation. I found out the value of CD, which I substituted in the, I found out the value of what is C. You find out the value of that, you will get the answer. That is the first equation of motion. For the second equation of motion, I just found out the area or the displacement, the area under the curve, that is the displacement. Find out the displacement, you'll get the second equation of motion. For the third equation of motion, I started off with the same thing. I found out the area under the curve by using the trapezium wala formula. And then what I did, I substituted the value of T from the first equation to give me this equation, that is V square is equal to U square plus 2A. As simple as that. That's all, guys. So these are the three equations of motion. I hope you guys understood this. Just to sum it all up, so these are the three equations of motion. V is equal to U plus AT, S is equal to UT plus half AT squared, V square minus U square is equal to 2AS. And apart from that, these equations of motion are definitely applicable for body with constant acceleration. So these are the equations that you are using, that you use in your motion wala chapter as well. So that's how you derive it. So we're going to do right now, what we're going to do right now is we're going to solve some questions based on this, the equations of motion. We'll solve some questions, and again, I want all of you guys to pause the video and give me the answer in the comment section below. So here's the first question is, for a motion, initial velocity is given as 12 meter per second, acceleration is 2 meter per second square, time taken as 15 seconds. You're supposed to find out what is the final velocity. Is it 30 meter per second, 37 meter per second, 42 meter per second, or 50 meter per second? Very simple question. So write on the formula. I would be using the first equation of motion. Let me change the color of the pen. So V is equal to what? V is equal to U plus AT. So V, the value of V is basically what we're supposed to find out. Initial velocity is 12. Acceleration is 2, time taken is 15. So you'll get it as 12 plus 30. So that gives you 42 meter per second. Very simple. So the answer for this question is 42 meter per second, which is option number C. As simple as that. Direct substitution, direct answer. Second question is, here we go. For a motion, V is, the final velocity is given as 15 meter per second. Distance or displacement is given as 25 meters. Initial velocity is given as 10 meter per second. You're supposed to find out what is the acceleration. Is it 3 meter per second square, 2.5 meter per second square, 2 meter per second square, or 1.5 meter per second square? They've given you the final velocity. Initial velocity, they've given you the distance or the displacement as well. You're supposed to find out the acceleration. So for this, because there's no time given, time taken is not given, I'm going to use the third equation of motion, that is V square is equal to U square plus 2AS. V square is 15 square, initial velocity is 10, so 10 square, plus 2 into A into distance is 25. So 15 into 15 is 225 is equal to 100. 110 square is 100 plus of 25 into 2 is 50. So 50a. That's what I'm going to get. So I'm going to take this to the other side. So 225 minus 100 is equal to 50a. So that's 125 is equal to 50a. So a is equal to 125 divided by 50, which if you calculate, so 5, 10, 5, 2, 5, 5 is 25, so you'll get us 2.5 meter per second square. Simple. That is the answer for this question, guys. The right answer is option number B, which is 2.5 meter per second square. As simple as that. Moving on to the third question, guys. Here we go. A person is traveling in a straight line if he covers a distance of 142.5 meters in 15 seconds with a constant acceleration of 0.2 meter per second square. Then find out the initial velocity of the person. So if you're supposed to find out the initial velocity, I'm not going to be doing the calculation part for this one because there's a lot of point values and it takes a little longer to do it. So I'm going to leave the calculation for you guys, but I'll show you the method to do it, and I'll substitute the value as well. But I want you guys to do the calculation and let me know what is the answer in the comment section below. So here's the question, guys. So let me write down the given data first. So S is given as 142.5 meters. They've given you the time taken, 15 seconds. They've given you the acceleration, 0.2 meter per second square. They have, you're supposed to find out what is U. So S is given, T is given, acceleration is given. So you're supposed to find out the initial velocity. I would go with the second equation of motion, that is S is equal to ut plus half at square, because there's no final velocity. You can have only one unknown value, and here in this case initial velocity is the unknown value. Substitute the values, it'll be 142.5. Initial velocity is U, time taken is 15 plus half into acceleration is 0.2 into time taken is 15 square. So just to simplify it a little further, 142.5 is equal to 15u plus it'll basically be 0.5 1 by 2, 0.5 into 0.2 into 225. So if you do the calculation, you would get the value of, you just substitute, if you simplify this equation, you would get the answer. So if you simplify that, you'll get the, on your right hand side, you'll get as 22.5. So that's what you're going to get when you multiply 0.5 into 0.2 into 15 square. So you'll get as 22.5. Take that to the other side, you'll get as 120. 142 minus 122.5, you'll get as 120. 120 divided by 15, it'll give you 8 meter per second. Like I told you, I didn't want to do the calculation because it takes a little longer. That's why I stopped it right here. So that's how you get the answer for this question, guys. I'm pretty sure that you guys will be able to do the calculation very easily because these are very straightforward calculations. So if you substitute the values, you will get this answer, and the answer is option number D, which is 8 meter per second. Simple as that, guys. Moving on to the fourth question. Here we go. Find out the value of displacement if initial velocity is 10 meter per second, acceleration is given as 0.1 meter per second square, and time taken is 20 seconds. Is it 240 meters, 220 meters, 300 meters, or 250 meters? So they give you you're also find out what is the displacement. They've given you the initial velocity, they've given you the acceleration, they've given you the time taken. Find out the value of S. So for this, I would go with initial, since the initial velocity is given, I'm going to go with the second equation of motion, that is S is equal to ut plus half at square, because I know the value of A, I know the value of T. They've also given me the value of U as well. Substitute the values over here. Once again, initial velocity is 10, so 10 into 20 plus half into 0.1 into time taken is 20 square. So that's 200 plus 1 by 2 into 0.1 into basically 20 square is 400. So you'll get it as 40. So 400 into 0.1 is 40. So 200 plus 40 by 220. So you'll get it as 220 meters. As simple as that. So the answer to this question, guys, would be option number B, which is nothing but 220 meters. As simple as that. So yes, guys, the questions are pretty simple. By that, by now that you already have figured that out. These are very straightforward questions. You just have to substitute the values and you'll get the answers. All right. Last question, guys. Here we go. A car traveling at a speed of 72 km per hour suddenly applies the brake with the deceleration of 5 meter per second square. Find the stopping distance of the car. You're supposed to find out what is the displacement. They've given you the acceleration. They've given you the initial velocity as well. You're supposed to find out what is the stopping distance. Is it 40 meters, 20 meters, 50 meters, or 36 meters? The question might seem a little tough, but it's actually pretty simple, guys. So the car is stopping, which means that the final velocity is 0 because the car is coming to a state of rest. Initial velocity is given as 72 kilometer per hour. Convert that to meter per second into 5 by 18. So 2, 9, 18, 2, 3, 6, 2, 6, 12, 9, 4, 18, 36. So 4 into 5 is 20. So that'll be 20 meter per second. So 72 kilometer per hour is 20 meter per second. I found that out. So acceleration was given. Now this time it's deceleration. So it'll be negative acceleration in other words. So it'll be minus 5 meter per second square because it's deceleration. So it's minus. Then, okay, I'm supposed to find out S. So you know final velocity, you know the initial velocity, you know the acceleration as well. You're supposed to find out what is the distance. So I can go with the third equation of motion, that is v square is equal to u square plus 2as, because there is no time taken given. So I'm just going to substitute that. So v square is 0, u square is 20 square, so that's 400. 2 into acceleration is minus 5, and you're supposed to find out s. So that's 400 minus 10s. So I'll take this to the other side. So 10s is equal to 400. S is equal to 400 divided by 10, which will give me 40 meters. As simple as that. So the answer to this question, guys, is option number A, which is nothing but 40 meters. That's all, guys. That's all from my side. And as always, this is your homework for today. Find out the value of initial velocity. If acceleration is 0.5 meter per second square, time is 34 seconds, and the final velocity is 50 meter per second. So you're supposed to find this out. What is the initial velocity? Put it on in the comment section below. I'll be looking forward to get your answers, to check your answers, and I'll let you know if you guys have gone wrong in any place. So that is it from my side, guys. Thank you for joining. Hope you guys enjoyed today's session. If you did, like, share, and subscribe. And if you have to reach out to me, if you want to ask me something personally, you can reach out to me at anup.manoran@vedantu.com. And whatever doubts you have, put it on in the comment section below, and put down your answers also in the comment section below. Thank you for joining. See you all on the next one. Take care of yourself. Stay safe, and bye bye, guys. Take care. Bye bye.